We are going to evaluate the area of an ellipse by using Green's theorem. Evaluate the area of the ellipse. There are alternative ways. For this question, we will use Green's theorem. Green's theorem says for simple connected curves, counterclockwise curves, the line integral over C is equal to double integral over the enclosed region. So for this one, D and C is the curve for the ellipse, which is counterclockwise. Double integral of qx minus py dA, let's say. So here F is the vector field with PQ. So we are going to evaluate the area by parameterizing C. How do we parameterize C? We say x is equal to 3 cosine t, y is equal to 2 sine t, and t is from 0 to 2 pi, so it will cover all the points on the ellipse. What about the vector field? For vector field, we may say f is equal to 0x, then qx will be 1, py will be 0, qx minus py is 1, so by using Green's theorem we can say it will give us the area because qx minus py is equal to 1, and the line integral will be double integral over the region D, double integral of 1, so it will give us the area of the ellipse. Area of D, which is the area of the ellipse. So area is equal to the line integral with this curve f dot dr. We said f is 0x, and remember the r is dx dy. So use the parameterization. X is 3 cosine t, then dx will be 3 derivative of cosine is negative sine, so negative 3 sine t dt, and dy will be 2 cosine t dt. So the line integral becomes x 0 times dx plus x times dy, so it is going to be 3 cosine t, dy is 2 cosine t dt. T is from 0 to 2 pi. So that is, well, we may use power reduction formulas. That is 6 cosine square t dt. For cosine 2t, is 2 cosine square t minus 1. So you may replace cosine square t with cosine 2t plus 1 over 2. So if you replace cosine square with cosine 2t plus 1, over 2 dt from 0 to 2 pi. We will have 3 cosine 2t plus 3 dt. So if we integrate cosine, will be sine 2t over 2, 3 sine 2t over 2 plus 3t from 0 to 2 pi. Sine 4 pi is 0, sine 0 is also 0, so this is going to be 6 pi minus 0, which is 6 pi unit squares. This is the area of the ellipse. Okay, a natural question is area of this ellipse. A natural question is if we choose a different vector field, would it be same? Can we choose a different vector field? Yes. For instance, at the beginning we said vector field is 0x and it satisfies qx minus py is equal to 1. Equivalently, you could choose another vector field, say negative y x, then negative y 0, so qx will be 0, py is negative 1, so it will satisfy qx minus py is equal to 0 also. Or you may choose different coefficients, like let's say 1 over 2, so minus y over 2, x over 2. This one will also satisfy the same property qx minus py is equal to 1. It doesn't matter which vector field you choose. If it satisfies qx minus py is equal to 1, then it will give us the same result. So let me calculate for the third one. For the third one, qx minus py is equal to 1 over 2 minus negative 1 over 2, so it will be 1. What about the line integral? Line integral will be f dot dr, so minus y over 2, x over 2, and the dr, remember, what was the parameterization? X is 3 cosine t, so the x is minus 3 sine t dt. Let me take dt out. And y is 2 sine t, so this is 2 cosine t, and we have dt outside with dot product. So if we calculate this line integral, we should get the same number, same expression. I should replace y with what is the expression for y? 2 sine t, so 2 sine t, and x is 3 cosine t. So if we do the dot product, it is going to be minus times minus, 0 to 2 pi, let me say. Simplify 2's, 3 sine square t, plus 3 cosine square t. So it became a simpler integral actually. Sine square plus cosine square is 1, so we have just 0 to 2 pi, 3 times 1, 3 dt, and this integral is 3t 0 to 2 pi, a simpler integral, so you have just 6 pi unit squares as the area of this ellipse. So it doesn't matter which vector field you choose, as far as it satisfies this property, it will give us the area of the enclosed region by C, by using the Green's theorem. F dot dr is equal to x minus py dA. So you may replace the double integral with a line integral and then calculate the area by calculating the line integral. Please visit the website for a categorized list of my YouTube videos. It is given below in the definition of the video. Subscribe and like.